out how to solve a equation using the Chinese remainder theorem, we have an example from our question bank, which is 7 mod 65. So we have to find the inverse of this using the Chinese remainder theorem. First things we do, we have this, the big number on the right side. This is n, so our n is equal to 65. Then we have to turn this n into two separate integers. So two numbers times each other should equal 65. Both of these numbers should be prime numbers. In this case, we have 5 times 13, which equals 65. This would be d1, and this will be d2. Okay, so we have 65. We have d1 is equal to 5, and d2 is equal to 13. Okay, so we have these three variables that we need. So now, first thing we do, we get the first number, the 7. We would say 7 x1, so we just times the number, mod of d1. Alright, so our d1 in this case is 5, is equal to 1. So we say what number times 7 mod of 5 is equal to 1. So, for example, if we say 7 mod 5, this is equal to 2, because 7 minus 5, we have a remainder of 2. So if you do 7 times 2, it's 14. 14 mod 5, still the same thing, we have a remainder of 4. But times 3 is 21. 21 mod 5 is equal to 1. So this is 3. So 7 times 3 will be 21. Then we have, again, 7, this time x2, mod of d2. In our case, d2 is 13. It's equal to 1, again. Now, what times 7 mod 13 is equal to 1? If we times it by 1, we don't get anything, it's 7. Times by 2 is 14. 14 mod 1 is equal to 3. Equal to 1. So x2 is 2. Then, this time, we have n over d1. Okay, so 65 over 5, which of course will equal to 13. We have 13 y1 mod d1. Okay, so in our case 5 is equal to 1. This equal to 1 is all set. Now we have y. So 13 y1 mod 5 should be equal to 1. So what number do we have to choose? So we have to go through it. So 13 mod 5, we can't have that because that will be remainder of 3. But if we do 26, which is times 2, it will be 25. If we make this, it will equal to 1. So this would be 2. So this becomes 26, 26 mod 5. If we minus 5 each time, we'll get a remainder of 1. Then we have the opposite. We have n over d2, which is 13. In this case, this would equal 5. So this one was 2. This would equal 5 y2 mod, once again, d2, which is 13, is equal to 1. Then we have y2. So what would y2 be? Is it 1? No. 2? No. We have to do trial and error for this. So if we try it, this would become, if we do a 13 times 3, this is equal to a 39. Okay? So, and 5 times 8 is 40. So imagine that. So 40 and mod 13 would equal to 1, which is 8. So we have these four. We have all the variables that we need. Now, from all this, we have the equation, which is basically a is equal to n over d1 times x1 times y1 plus n over d2 x2 y2. All this is the equation of mod 65, which is basically the same as saying mod n, which will leave mod n, which is mod 65. So let's input all our numbers into here. Alright, so let's go down. Alright, so we have a is equal to our n is 65 over, we have d1, which is 5. Then x1, which is 3, and y1, which is 2. Plus, let's put this all in the bracket, plus we have our n over d2, which is 65 over 13 times 2 times 8. All this mod 65. So now let's calculate this. This would be 13 times 3 times 2 plus 5 times 2 times 8. All of this mod of 65. So we calculate these. 13 times 3 times 2 would equal to 78. And 5 times 8 is 40. 40 times 2 is 80. 80. All of this in a bracket. Mod of 65. Now, 78 plus 80 would equal to 158. Mod 65. So, in this case, we minus 65 each time. We would be left with 28 mod 65. So our final answer is equal to 28. So this is how you solve it using the Chinese remainder theorem.